A 17-year-old man presents to the emergency department with fever, nausea, and a diffuse red rash involving his trunk and extremities. His temperature is 38.9 degrees Celsius, 102.02 degrees Fahrenheit, and blood pressure is 78/49 millimeters mercury. His mother tells you that he had gotten in a fight at school, resulting in a severe nosebleed, which he self-treated using large amounts of tissue. Culture obtained grows a coagulase-positive, gram-positive cocci. What is the likely mechanism which caused the symptoms in this patient? Choice A, large increase of CAMP signaling within cells. Choice B, binding of bacterial antigen to CD14 receptors causing immune cell signal cascade. Choice C, cross-linking of T-cell receptor V-beta to class II MHC molecules. Choice D, binding of CD40 ligand to CD40 on B cells. Choice E, degranulation of mast cells causing release of inflammatory mediators. I'll wait 5 seconds and then I'll start explaining the question. So this should be a relatively easy question, although I hid the answers behind incredibly verbose answer choices perhaps. But it should be really obvious to anybody reading this question that this is toxic shock syndrome. And of course we have the culture growing what appears to be Staph aureus. And we know one of the causes behind toxic shock syndrome is the signaling between T-cell receptors with class II MHC molecules, so that's why choice C is the correct answer. Not a whole lot to say here, actually. You gotta know this. USMLE really likes writing answer choices and questions in incredibly obscure, verbose ways, so I tried to replicate that here. But anyway, aside from choice C, every other answer choice here you can rule out because honestly they're all really high yield as well, and you should recognize every single one of them. Choice A, large increase of CAMP signaling within cells. I mean, that could signal any number of things. Any drug or any antigen that can activate GS protein will result in a large amount of CAMP. And in fact, inhibition of GI protein will also result in large increase of CAMP. So in terms of infectious disease, obviously we're thinking like pertussis that inhibits GI. You have cholera and heat labile toxin from E. coli, which can cause diarrhea. Both of those increase CAMP in the gut. Those are some of the big ones off the top of my head. Choice B, binding of bacterial antigen to CD14 receptors causing immune cell signal cascade. I was kind of a jerk here and I just wrote CD14. CD14 is actually toll-like receptor, especially toll-like receptor 4. This binds to the LPS on gram-negatives and causes endotoxic shock. This is also very high yield. So if I had a similar question to this one where it was obvious that the patient had some kind of septic shock and the culture instead grew a gram-negative like an E. coli or something, this would be the correct answer. Choice D, binding of CD40 ligand to CD40 on B cells. I mean, this is just for activation of B cells, which allows them to differentiate into different types of immunoglobulin. This is more of an answer choice that you'll see in one of those immunodeficiency questions, because this is the mechanism where if CD40 is deficient, you'll get hyper IgM syndrome. I just threw it in here as a distractor. You should have recognized what this is. Choice E, degranulation of mast cells causing release of inflammatory mediators. I mean, that's obviously type 1 hypersensitivity. I don't know what to tell you. Obviously, anaphylaxis, bee stings or whatever. So the takeaway from this question is that if you see a toxic shock syndrome question and they're asking what's binding or what's causing the cytokine cascade or whatever, your answer is going to be linking of T-cell receptor to class II MHC molecule. And they can write this any number of ways, but they're always, or at least almost always, going to say T-cell receptor class II MHC molecule in some way. Anyway, I hope this video was helpful. I'll see you in the next one.